Hello, and welcome to Lessons with Laurie, where we look at some of the big ideas and concepts in mathematics, kindergarten through grade 5. My goal in doing these lessons is to support you, the parents and grandparents who find yourselves in a new situation, trying to support the learning of your child or grandchild in a distance or remote learning setting. I want to continue now with our discussion about place value. It's a concept that is introduced around the middle of first grade. So let's pick it up and think about where place value shows up in second grade. Here's a problem typical in second grade where they're asked to add two-digit numbers together. And you might say, Laurie, how could they possibly get 811 as an answer to this problem? Well, let me share with you how they might explain it. They would say 8 plus 3 is 11, and 2 plus 6 is equal to 8. So I have 811. Well, certainly you can see that there's a misconception about place value here, but the rule about addition of digits is what they are recalling. Even here, when they start to think about this procedure that they have been told, and this recording here, this is what it sounds like when they explain their reasoning. They say 8 plus 3 is equal to 11, so I write the 1, and then I've been told that I'm supposed to, quote, carry, so I put this tick mark up here even though I don't know what the notation means. And now I see 16 plus 2 more, and I get 18. Again, that's what they're thinking in their mind. That's why it's so important for you to ask the question, how do you know? Can you explain your reasoning? So that's a misconception. How would we develop it in second grade though? Well, we'd want to add 42 plus 15 by first building a model for it. We'd use our base 10 pieces and followed that with being able to draw a sketch. This is what it sounds like when you now ask them to explain their reasoning. They would say, well, I'm going to add my 10s together. 40 plus 10 gives me 50. 2 plus 5 gives me 7. So I've built it with base 10 pieces. I can do a quick sketch and I get an answer of 57. This then progresses to being able to record it in a place value chart. You can see now I have labeled my columns with our place values of 10s and 1s. And as I add my two numbers together, I'm adding in the same columns. I'm adding the same place values together in order to get the correct answer. Well, when I do that, I'm using place value, of course. And you might say, well, Laurie, what happens though when I add my 1s and I have a sum that is greater than 10? Well, this is what it then looks like. We again build it with base 10 pieces and do a quick sketch in our place value chart. In our place value chart, you can see that you've represented the numbers 37 and 56. And in doing so, our 1s add to a sum that's greater than 10. And so I replace or I trade in my 10 1s for 1 10. That's what that means when we record it in the place value chart in our standard algorithm. That little tick mark is really representing a group of 10. We want students to learn how to add two-digit numbers or multi-digit numbers with understanding. Let's see what it looks like when we use place value for multiplication. When students are introduced to multiplication in third grade, we think of multiplication in an array fashion, meaning 3 times 4 can be thought of as 3 rows of 4 columns. And by counting, we end up with a product of 12. We certainly want our students to know their multiplication facts, but we want them to learn it through meaning and not by sheer memorization. So we move from the array model to an area model. When we're multiplying 3 times 14, you can see that I have 3 rows of 14 using my base 10 pieces. Well, if I push these pieces together, you can see where the rectangle is. I have a rectangle whose dimensions are 3 by 14. Using place value, I understand that 14 is a group of 10 and a group of 4. So 3 times 14 can be thought of as 3 times 10 is 30, 3 times 4 is 12, for a product of 42. That's really third grade multiplication. Now when we move to fourth grade and we are multiplying two-digit numbers, you might question, why do we have these area models that you may have seen? Well, let me explain how the area model relates to place value. 37 can be thought of as 30 plus 7. 14, again, is still 10 plus 4. And if I multiply with understanding and by using the concept of place value, I know that 37 times 14 means 10 times 30 is 300, 10 times 7 is 70, 4 times 7 is 28, and 4 times 30 is 120. When we then record this with understanding and by using the concept of place value, this is what it initially looks like. 4 times 7 is 28. 4 times 30, it's not just 4 times 3, 4 times 30 is 120. 10 times 7 is 70. And 10 times 30 is equal to 300. Now that may look like a lot of steps, but it's the precursor to the standard algorithm that looks like this. 4 times 7 is 28, which is a group of 8 and 2 more 10s. 4 times 30 is 120, plus 2 more 10s is 140. And notice how place value is playing a role here. 10 times 7 is 70, and 10 times 30 is 300. Again, place value. When I add together these two partial products, and that's how we refer to them, these two partial products, that's where 148 comes from. These two partial products, that's where 370 comes from. We're learning multiplication with meaning. So when you see the models and the sketches that students are using, please trust it's because we want students to learn with understanding so that there are no misconceptions later. Thank you.